So finally, sorry for a bit late start. My computer and the recording equipment didn't like each other. And I blame everything on the recording equipment. It can't be my machine. Long ago, when I started working with IT, I heard about a legend. A legend that once upon a time, there will be true single sign-on. That we can actually sign in once to the computer and access all applications, no more password prompts. And behold, the legend has become true. I mean, nowadays, this is my lock screen. It's not the PowerPoint template. Nowadays, I can walk up to my computer. It recognizes me. I can start a browser. And just to show you I'm not cheating, settings, choose what to clear. I'm clearing everything. So I know hidden state here. I can go to portal.office.com. And I am signed in. That's pretty cool, isn't it? It actually works in Google Chrome as well if you have a special plugin to communicate with the Windows 10 ecosystem. You see, it flashed by that it showed the prompt to enter an account name, but then it found out, oh, you are already signed in Windows 10, and my computer is joined to an Azure AD, so it just works. And it's great, and this talk could be finished here, but I'm a bit disillusioned, so I think, okay, but how? I mean, we've strived for this for so long, and it works. So let's go back and review a bit of a history of authentication. I'm going back 2,000 years ago first, to these guys. This is the first documented use of the term password, which literally meant a word you needed to pass those friendly guys to get into the Roman legionary camp. The first documented use of passwords in the computer system context is in the 1960s, when the time-sharing machines emerged. This old thing in the background here, it's not fridges, it's a computer, and it was horrendously expensive, so each user just had an allotted amount of execution time, and they could sign on with an account and a password to gain access to that, to the computer and use their execution time. Just a bit of trivia, because I was looking for 1960 picture of a computer and found this one. Anyone recognize any one of these guys? We owe them a great deal. Without those two guys, half of us at least would probably not have had a career in IT, because IT wouldn't have been what it is. The guy sitting at the keyboard is Ken Thompson. He invented Unix. That hipster standing next to him is Dennis Ritchie. He invented the C programming language. So thank you, guys. But this talk is not about trivia, it's about single sign-on. So what about single sign-on here? Well, not so much, because, well, in a way, it is single sign-on, because you signed into your terminal once, because you had one computer to work with, and you were signed in. That's single sign-on, right? And things were quite happy for a time, and there was no need to explore anything else. Until maybe in the 70s, the terminals at least were not that expensive anymore. So someone bought a terminal to have in their home or a remote office. They bought a modem and set up a remote access service to call into the mainframe. And now you wanted to authenticate the caller directly with a password, and you wanted the same password. So Radius was invented, where you sent the password along to the mainframe and it responded, yes, this is the right password, let him in. Radius is still used for things like network equipment, firewall switches, network level authentication stuff, but as a web developer, you never touch it. And I actually brought up the Radius example to point out something that is bad with it, and it's the password being passed around. enter the password once, and then we pass the password in clear text. So all the remote access service in the middle here actually has access to the user's password, and we don't want that. So let's move on to the 80s. What happened then? In the 80s, not so much single sign-on because we've got personal computers. It was in your office, locked. If you got into the office, you could get all the papers and you could get the computer. Then in the 90s came along a file server and the need once again to authenticate in a network context. And we created domain controllers. This was the idea of the corporation being the master. You had one domain controller being the security master of the corporation, and nothing existed outside of the corporation. Each company was their own bubble. They couldn't communicate with each other. And sign-in happened through LAN manager, NTLM manager, version 1, 2, whatever. It's kind of a regex there with the versions of the protocols. How this works is that the user enters the password at their computer. Their computer performs some hashing, sends the hash over to the file server, which does another set round of hashing, sends that hash over to the domain controller, gets a yes or no back, and then the file server can respond with a file. The problem here is still we have the notion of one security domain. Everything, both the client and server, need to belong to that domain and be a member of the domain. And we also has a problem that everything is based on passwords. And these hashes are assumed to be a one-way function. But somewhere along the in time, someone will find a flaw in the hash algorithm, or simply computing power will be so powerful that we can brute force the hash. So using a password as the base for the actual authentication to each server we want to go to is bad. There's also the hash attack. If I set up a rogue server and make the user connect to my rogue server, I can get a hash that I then can pass on to the real server to get the files of the user. So in the early 2000s, things moved on once again, and Windows moved on to not invent, Microsoft moved on to not invent their own protocol, but to instead rely on industry standard from MIT, Kerberos. And now we are approaching how a modern authentication protocol works, with the password being still entered at the client, and the client is still an active client knowing and running code to understand and handle the sign-on protocol. But the password is still actually hashed, and the hash is passed, but not to the resource server, the file server here, but it's passed to domain controller that sends back a ticket, some abstract thing that can be stored in memory on the client to prove that you have a session. And this is good because the password usually is valid for years. It's hard to change passwords, but tickets can be expired in typically 10 hours. So if you lose track of a ticket, well, it's no use for an attacker after 10 hours. If we want to access the web server here, the user machine, a client machine, would send this golden ticket, it's called a ticket granting ticket, to the domain controller again and mark it that I want to access this web server. And back we will get an access ticket for the web server that we can then use to request the web page from the web server. And this is also good because this the hash attack, where one resource server would get something that they can use to authenticate to another resource server, is no longer possible because that blue ticket is only valid for the web server. If I want to go to another web server, I would have requested a green ticket from the domain controller. This one drawback though with this, and it is, imagine this is an intranet site. And then we want to be able to go to surf the intranet site on our phones or from home. To do that, we expose the intranet site on the internet, but we can't log on. Because we need a domain-joined computer that is actually allowed to connect all the way to the domain controller. So Kerberos is once again this corporation thing. Within our bubble, it works great. in today's open distributed work environment where we have software as a service services on the internet that we want to connect to from different providers, it doesn't work anymore. So no, we have to move on. And something was wrong there. Let's see here. But I wanted to show you this history anyways, what has happened. We moved from passwords being passed around to hashes being passed around to tickets, abstract tickets. And this is a good development. So modern authentication protocols build a bit upon this experience. So we are now through the first part of the title slide. Why not use Kerberos, NTLM, or Radius? The old legacy history things. Let's move on to how things work today. A web-based single sign-on protocol. It basically means this: from a client, we call a web server with a GET request, get/profile. We have no session on the web server, so the web server makes a redirect and redirects the user to an identity provider or log-on server with the question, who is this? And the sign-in server makes a redirection or post back, this is Anders, and proves it by attaching a piece of data, a data structure with information about me that is signed by the private key of the identity provider. And this is how all the modern authentication protocols works. It's good because we have no domain membership restrictions. I mean, the client here is just a stupid web browser. It's not involved really in the authentication process, just passes the data around. And there's also no assumption anymore on a password being used. The only thing we know is that the client is redirected to the identity provider, and at the identity provider they are somehow authenticated. It could be by prompting for username and password. It could be by a smart card. It can be Windows 8 integrated authentication, that the IDP can check that I have an active session in Windows. It could be some other kind of hardware key or anything, multi-factor authentication, etc., which make us the client over there and the web server are totally independent of how the actual authentication takes place. We just know that it is done. So I wanted to dig a bit deeper into how this actually works. We have the get profile, that's right. Typically we get a 303 back from the web server when it finds out that you have no active session. That 303 contains a redirect with a query string with some state carrying over and a parameter saying this is from this web server. So then when the client requests this from the IDP knows where to send the user back once authentication is complete. The IDP does the authentication and then typically responds with the 200 containing a small HTML document with a hidden form and hidden form fields that just contain a response, this signed document we wanted. The reason that we are using an auto-posted form here is that the amount of data is usually too much to cram into a URL parameter. There are length limitations. I'm looking at your Safari. And then we post that, the browser will post this back to the web server. The web server will validate it at this special callback point where a protocol handler takes charge, validates the income identity, and responds with the redirect to the original profile page we wanted to visit, and also setting an authentication cookie. I'm going to show you this in the context of, let's see if things actually switch back. Yes, you can see what I do. Great. The first demo here is a SAML2 authentication that will take place. And let's see if my Chrome plugins are happy today. I tried to access this secure link, which requires authentication. So when I try to access that, things happen. What I got here was that first I have enabled normal ASP.NET authentication mechanism here saying that if you're not authenticated, redirect to there. That place where we are redirected is SAML2/sign-in with a return URL parameter that says that once you have successfully signed in, please return to this location. And that is the entry point of SAMl2 authentication on this this application, where it issues that redirect over to the identity provider, and it contains this encoded SAML authentication request in the query string. And I'll show you it's here on this. Now we can take it here. It's better. So it's a piece of encoded XML where it says that, well, what's interesting here, it basically says, please authenticate the user. And hey, this is from this application. A URL is used as the identifier of the source application. And we also, in this message, contain the callback path. Please post the resulting message to this URL. Now in this case, I'm using a dummy IDP that I've built, which is also available on the internet if you're playing around with SAMl2. So this does no validation in anything. I mean, I can add whatever properties and stuff I want. Now I'm John Doe today. But I can send a proper SAMl2 response. And we can see that it was posted here, and we'll have a look at what was posted. It's a SAML response which contains a lot of information saying that, well, this is issued by this IDP, there's a signature, XML signature to prove that it was indeed from that IDP, and the status code, and somewhere down here, further down, there's a name of the user, John Doe, and there's also some extra information about the user, and it should be attribute statement somewhere here. Scroll down. Attribute statement, attribute value, John Doe at example.com. So demoing, showing a single sign-on flow is really boring, because when it works, there's really nothing to show. But we got redirected, we entered our user information, we got redirected back. So let's continue with, and wrong button. I hate when that happens. So we have now talked really about, that was a demo of SAMl2, and from the same era, the early 2000s, is WS Federation. And at this point, I was thinking about a detailed comparison between SAMl2 and WS Federation, but it can really be summarized very simply. One is an open standard, the other is Microsoft. They can do roughly the same. They are very much equivalent. They just have different format of the protocol messages, so they are not compatible. Then moving on a bit in history, I want to jump forward to 2006, because something really interesting happened in 2006. A company was founded in 2006 that we now make quite a lot of use. We even have them on our name tags today. What company can it be? I at least have my handle here. Twitter. Right. And Twitter wanted to expose open APIs. So they wanted a client somewhere to be able, web client to be able to connect to a third-party website, which would be able to access the Twitter account of the end user. Not because we do trust that particular website anything, but because I, as a user, has approved that that website can use my Twitter account, but not yours. You would have to approve it yourself. So how would this work? Well, we need to introduce some kind of authority where we can get an access key or access token that is sent over to the Twitter API that can then somehow validate it, usually by loading once the public key of the authority, and then it can validate that all incoming tokens are properly signed. We'll move on to in 2006. Something else happened that revolutionized and turned web development upside down. A new standard was drafted in 2006. Anyone dare to guess what that was? Well, you're ahead of your time. Can you take that in 4 slides? Another standard was drafted. XML HTTP request and AJAX. I remember the first time I was using hitta.se with an AJAX loaded map. It was magic because you didn't have to load the entire page. It loaded tile by tile when I scrolled. It was pure magic. But it also means that the old ways of authentication hit a dead end. Usually in a server-side web page, we do have a cookie to establish a session. And then when we have a form, to avoid cross-site request forgery attacks, we need to prove that the user first loaded the form from the right web server before posting it back, because otherwise we have an attack vector. To remedy this, we put in a hidden value in the form when it is loaded. We set a cookie with the same value, and when posting, we validate that they are the same. Enter single-page applications. Where is the form generated? Not on the server. It's generated in the client application. So this entire mitigation of the cross-site request forgery attacks is not possible with the client-side application. So let's just forget it. No. We need, when we have an active client calling an API, we need some kind of key that we can get from an authority to pass on to the web, to store in memory of the client and pass on every request to the API, and the API needs some way to validate it by loading a public key, maybe, from the authority. And then in 2007, yet another thing happened. Okay, we're 1 year ahead. What was the most revolutionizing moment in tech history in the OO decade? In 2007, there was a presentation of something. If I can find one person in this room not having such a device, yes, the iPhone. And with iPhone came the apps. Apps that call a backend API need to authenticate, probably by getting some kind of token from an authority, storing that in memory with the app, passing it on in every call, and a way for the REST API to validate it. And these all 3 things look fairly much the same, don't they? So please, what did you say previously? OAuth2, or OAuth previously, but I'm jumping to OAuth2 here. So what is OAuth2? Well, we had these 3 new problems, and we needed a new solution for authentication. OAuth2, what does it do? Well, it handles API authorization. You have some kind of authority where you can get an access key that you can send on to the resource or API you want to use, and there's a validation mechanism. So what about single sign-on? Well, let's see. We can do that because we can use our key to request from the API the profile information of the current user. And if we can get back some profile information from the API, we can make an assumption that the user is indeed authenticated. But previously I showed you that this was how it should look like. Modern authentication protocols. There's no API server here, there's no keys. So that's the reason why OAuth2 is also on this strike-through line. OAuth2 is an authorization protocol to be used to prove right of access to resources. It's not a single sign-on protocol meant to be used to establish sessions. But someone fixed that by introducing OpenID Connect. So we do the same handshake. But instead of getting an access token, we get this kind of signed document, an ID token, which is destined for the web server. So we can establish a session. And then, of course, these can be combined, so we can get an access token in the same process that can be used to call the API. And also we have another interesting thing here in OpenID Connect and OAuth2, which is consent. I mean, I love being able to use my Google account to sign up to various websites. I don't want another password, and I don't reuse passwords. But hitting sign up with Google is perfect. They get my name and email address, nothing more, and I'm signed in. But sometimes I get to an application that wants to do more. The thing is that the access token I do get is restricted. Even though I have the complete access rights to my Google account, I don't want to give that access rights to a random website on the internet. I want to be able to consent explicitly to exactly what is that website allowed to do. We can do that as a consent screen, where I can see what is this website allowed to do in my name. Typically, when I sign up to a web application, I wanted to be able to see my name and email address. If it also requests access to read my Gmail, send Gmail on behalf of me, read my calendar and alter my appointments, probably not. And this is what I think is so great with OAuth2 and OpenID Connect. It's powerful. And it's a model where nobody trusts nobody. I am the owner of my resources. I can give consent exactly what access rights to delegate to certain applications. So, do you think it's complicated yet? Okay. Sorry about that, because I'm going to make it worse. I want to talk a bit about security properties of authentication protocols and how to implement them. There are a few things you need to think about. They should not be password-based, but use these abstract tickets. They should be cross-site request forgery safe, and not just securing the API access, but also the actual login flow need to be cross-site request forgery safe, as the logout flow need to be that, and the initiation of logout needs to be authenticated somehow. We also need to validate signatures, and validating signatures when talking XML-based signatures in WS-Fed and SAMl2 is horribly hard, so it needs to be correct validation procedure of the signatures. We need to have secure config with signing keys being distributed in a secure way. Endpoint addresses need to be distributed so that we can't trick an identity provider to post detailed information about me to someone else's server. Key rollover, the signing keys should be changed, and we should have replay protection so that an access token that one API has got, that API shouldn't be able to turn around and use that access token to call another API. That's done through audience restrictions. And there should be time limit. An access token is sent across the wire for every single call. It might be intercepted. It shouldn't be valid for maybe more than an hour. Then we should refresh and get a new one. The good news is that all three large authentication protocols fulfill all of these properties. They are well designed and can be used. The bad news are that they fit multiple purposes and works in different contexts. And that was horrible flickering. So if we start from the beginning, interop. SAMl2 has been around for long and has a broad industry adaptation. It works with many different vendors and platforms. But then you have things like SharePoint that only talks WS Federation. SharePoint on premise, that is. ASP.NET is great because ASP.NET Microsoft has excellent support for WS Federation. They've had it all since an HTTP module, OWIN middleware, ASP.NET core handlers. And SAMl2, I have an open source component for ASP.NET that's quite widely used that supports all of these generations. OpenID Connect is supported on the OWIN, in the OWIN system and ASP.NET Core. So for an ASP.NET developer, we can choose. And then we have multi-IDP federations like universities. You can connect to not just one external upstream provider, but to all universities at once. SAMl2 can do that. And finally, we have the modern world. Mobile apps, single-page applications, API access, user consent that only OpenID Connect can handle. So this is not so much about picking the right protocol. I'm sorry if I've been misleading you with the title. This is about finding, if you're happy, one that works. But probably we won't find one that works, because chances are fairly big, unfortunately, that you're stuck with an identity provider that talks SAML2, or if it is ADFS, it also talks WS Federation. And chances are you're building a modern application and you need OpenID Connect. So what to do? Well, you have to put a bridge in between. So it's time for my second demo. And let's see if I can get this to work. Let's see, like this. No, wrong browser. Here we have it. Don't you all admire my web design skills? Okay. I usually tell my kids that for a job I design login buttons. But that's a lie. I don't design them, the actual graphical thing. I let someone else do it. But I build login buttons. What I have here is a client-side application. This is the most ugly single-page application you've ever seen, probably, where I have at least a login button. So I'll hit it. I'm now redirected. And before I hit that, I was supposed to click F12 and bring up this panel. New try. Login. So what I got here is that I was redirected to an authorized endpoint of an Identity Server 3 instance, where I have a nonce and client ID. The important things here are that in the URL, I say that, well, this was from a client or an application called client side. I also say that when you're done, please send the response to this address, which is localhost on a specific port. Of course, Identity Server keeps a list of approved redirect URLs for this application, so you can't send in just anything. And then I've sent in a response type of ID token saying that I don't want a token, which would mean an OAuth2 bureau token. I want an ID token. I want to know who this is. And finally, a scope saying that I'm using OpenID Connect. And beside that, I want the email of the user. So I said that this would be a bridge. So let's click on the SAMl2 button. So now I made an OpenID Connect implicit flow call to my identity server. The identity server makes an call to an upstream identity provider. And we are once more at my dummy provider here, where I can just click sign in. Oh, there we are, login. Now we get to the consent screen. Now it says that, hey, are you aware? We can see that I've established a session on the identity server, this broker or intermediate, as John Doe. And now it's asked, do you really want to entrust that client application with your user identifier, that's just a GUID basically, and my email address? Well, yes, I want to. And I'll just bring back this SAML panel just alone. And what no, we can take it here. What I got here, I was redirected to a URL where there's a fragment containing an encoded ID token, which, when it has been unpacked and validated, looks like this. And once again, single sign-on demos are boring. But I wanted to show you that you can bridge them together. And of course, you could have, from ID server, you could also request an access token and protect an API and so on. There are great tutorials in Identity Server 4 and 3 how to do that. So let's get back to this. So to summarize a bit, what we're saying is that, first of all, building single sign-on should always mean using a real single sign-on protocol. I mean, I was in a project a couple of years ago. When I came into the project, one of the developers said that, hey, I looked at this and the OpenID Connect was saying things, they look complicated. But I found this blog post, how to create access token based on passwords. And there were passwords and hashes, and it was, of course, vulnerable to pass the hash attack. So don't try anything else. You should use a real proved protocol. Anything but these three, WS Federation, SAMl2 and OpenID Connect, is probably wrong and contains at least one security vulnerability. So what to pick? If you're using purely Microsoft things, especially purely Microsoft on-premise things, WS Federation. Active Directory Federation Service, ADFS, works great with WS Federation. They claim that they can do OpenID Connect, which is nearly true, but they have done their kind of styled it to their own ways. You can't use a standard compliant JavaScript OpenID Connect client with ADFS. It won't work, period. If you need interoperability with other vendors, services, products, use SAMl2. And I think SAMl2 is a good option also with ADFS, because then you won't be tied to ADFS with WS Federation. You can work with other identity providers if it would be replaced. And finally, in the world we have APIs, we have single-page applications, mobile applications, OpenID Connect. And I would love to say use OpenID Connect all the way, but I can't, because vendor support is horrible. I mean, we are developers. We like new stuff, right? Who would prefer a 10-year-old technology stack compared to something new? Well, I guess that. IT pros, on the other hand, or operations people, they're happy with the 10-year-old server because it has been working for 10 years. Can't we just continue to use it? And then it won't do OpenID Connect. And also many vendors in this area, having created and invested in a lot of money in SAMl2 and single sign-on solutions, they are not that fast to move on to OpenID Connect. So you will probably get stuck, and then we have the bridge. So I guess the result of all of this and the entire talk is a sales pitch to use Identity Server, which is open source. But it's a great product that lets you bridge between the protocols and mix and match in a way that you need. So that was what I had. Any questions? Nobody's sleeping? That's always good. I mean, there's usually at least one sleeping at the back. Nothing. Okay. Well, thank you so much for attending then.